Is it visible to all?
Yes, sir.
Yes.
Yes,
Okay.
sir.
Yes, sir.
Good morning, all. Sorry for the delay. So, in this session, we'll be discussing about. We'll be starting the third module. Okay, in your third module, as we shall quickly go through the syllabus whatever we have in third module. See, in third module, we have the concept of combinational circuit. Okay, so in this whole module, we'll be learning what is combinational circuit as actually is. Okay, after knowing what is combinational circuit, examples of combinational circuits, we have the concepts of, so this whole chapter, the very first chapter deals with all the possible combinations of combinational circuit. The second chapter, we have the implementation of this combinational circuit. That is, we have implementational of combinational circuit. Example is we have multiplexers, okay, decoders, encoders, and we have a very important concept called programmable logic device and programmable logic arrays. Okay, PLA and PLDs, PAL. Okay, so there are two concepts. One is PAL, programmable array logic, and programmable logic arrays. Okay, you need to know what is the difference between those two concepts and the implementation part of it. Okay, so considering this whole, okay, we shall try to take up each concepts and we shall dive into our discussion. Okay, so here as we can go here, we shall just go with it. Okay, now as you can see, observe, see, one is the very first concept is, you need to know what is the difference between your combinational logic circuit and your sequential logic circuit. See, in electronic circuit, in any electronic circuits, we have two types of circuit. Okay, so one kind of circuit we call it as sequential circuit. Okay, another one we call it as combinational logic circuit. Okay, so what is the difference between sequential logic circuit and combinational logic circuit is my very first question. So in this first chapter of this module, we'll be discussing about these concepts in detail. One is, we will be knowing what is actually a combinational logic circuit is, what is the difference between sequential logic and combinational logic circuit, example for both the circuits, and we have a concept called gate fan-in. Okay, what is actually gate fan-in is, and next we have what is timing diagram. So a representational of any logic circuit can be represented using your timing diagram. So this is what this agenda of this today's discussion. Okay, so now we shall start uh, just go through the syllabus now. Okay, we have the concept here. Okay, so next here we need to know what is the difference between your combinational and sequential circuit. See, combinational circuit is nothing but, let's consider this as one circuit. See, in this circuit, I have my inputs. Let us say this is inputs I1, this is I2, this is I3. Okay, so these are all my inputs here. Okay, these are the produced outputs of this particular circuits, that is O1, O2, O3. Okay, so as you can see, my output is dependent on my input here. So there is one single circuit here in which your output is completely depending on your input. Okay, so this we call it as combinational logic circuit, or the combination of both the inputs and output. Logically we'll be calling it as combinational logic circuit. Okay, so next we have sequential logic circuit. So as the meaning suggests, what is sequence? Sequence means what? One after the other, so that it will be subjected to the first circuit first, Next, the output of the first circuit will be subjected as to the second circuit. The output of second circuit will be taken as an input to your third circuit. Likewise, let us say this is my circuit C1, this is my circuit C2, this is my circuit C3. This is my input, this is my input IC1, this is my input for your circuit 1. So the output of circuit 1, that is OC1, will be acting as input to your circuit 2. The output of circuit 2 will be acting as your input to your circuit 3. So that this output, the final output, is not actually depending on the first input. Instead, it is depending on your previous circuit output. Okay, so these kind of circuit, I'll be calling it as sequential logic circuit. Okay, so this is the in combinational logic circuit, your output is directly dependent on the input, whereas in sequential logic circuit, every output will be acting as input to your next subsequent circuit. Is the concept clear? Can we go further?
Yes, sir.
Yes. Okay. So next we have having this as a basic prerequisite. We'll move to the next concept. How to design a combinational logic circuit. This is my first question. Okay. So there are few previous steps that we need to follow. What are all the exact steps that we have to follow? So one is your first step is problem definition. Whatever the problem which he has given you in a to designing of a combinational logic circuit, we need to analyze the problem what he has given. Second is we need to know what are all the available inputs that we have. So input is one main thing that we need to concentrate on. So what is the actual input we are subjecting it to? Next, as in any digital problem statement, we need to combine or we need to assign some letters or symbol to your inputs and also your outputs. That is the third step. Fourth step, I will plot a truth table for the existing problem. Fifth step is I will be deriving a Boolean equation from your circuit. Next, I'll be drawing your circuit diagram, that is logic diagram. So this is your steps in designing a combinational circuit. Okay, so this is one thing. Now let's take up an example. Let's take up an example so that we can understand very clearly about this particular concept. Let's go with one particular example. See, the example goes like this. Design a combinational logic circuits with 3 input variables that will produce a logical output. Okay, logic 1. So this is 1. Okay, logic 1 output when more than 1 input variables or logic 1. Let us say what he is telling is how many number of inputs he is taking. He is taking 3 inputs. Let's say my input is A, B and C. So if there are, let's say, what is some values. Okay, I'll be writing as 0, 0, 1. Okay, so another example is I'll take 1, 1, 0. Okay, so here in this input, say these are my input 1. Let us say this is my input 1, this is my input 2. Okay, so in input 1, what he is telling, that will produce a logic 1. I need to produce logic 1 or high when your output, when more than 1 input variables are logic 1. So here I have single one, so my output is 0. Here I have more than ones. Okay, more than single one, so 2 of my inputs are high. So in this case my output will be high. Okay, so this is what your problem is. So how do you approach this problem? Okay, how do you approach this problem? So let's say we'll go with the solution part now. We'll go with the solution. Let's say I have this, I have my 3 inputs. Let us say A, B, C. Now we shall try to write the output. So what is the output of the first input here? I have taken here 0 to 7. Okay, so this is my binary representation of all the numbers. So this is 0, this is 1, this is 2, 3, 4, 5, 6 and 7. Okay, you people know how to write this. Okay, simply 0, 0, 0 is represented as 0 can be represented as 0, 0, 0. Okay, so this is 2 power 0. Okay, this is 2 power 1, this is 2 power 2. Another logic is this is 4 to 1 code. Okay, so simply everything is 0, it is 0. If 1 has to be represented, I'll be representing as 0, 0, 1. Okay, so now let's go and solve this problem. Okay, how do we take? So what is my output here? Let us say, what is my output for first input now? What's my output? So here it is 0, 0, 1. It doesn't contain any one, so my output is 0. Next, how many number of ones I'm having? I'm having single one, so my output is 0. Here it is again 0. Here I'm having two ones, so your inputs is more than ones, so my output will be 1 here. So again, next, here it is 0. Here I have two ones, so it is 1. Here I have two ones, so it is 1. So here I'm having three ones. So here I'm having more than one. So the output is again 1. Okay, now what is my next step? What is my next step? After writing your truth table, I need to write my this thing, or the circuit diagrams. Okay, let's see here. I need to write my k-map for this. I need to simplify this whole boolean expression. I want to reduce it to into an expression. So let's say I'll be writing a k-map for this. Okay, let's take up k-map. So I'll be writing a k-map for this. So how many variables I'm having? I have about 3 variables. Okay, 3 variables I'll be taking. So one is let us say I have, so for 3 variables it is 1, 2 and 3. Okay, this is sufficient. Okay, so there is no problem, I think, with respect to writing your k-map. Okay, one side I'm having A, another side I am having BC. So this will be your 0, 0, 0, 1, 1, 0 and 1, 1. This will be 0 and this will be 1. Okay, so I'll be just writing what is 0, 0, 0, 1, 0, 0, 0, 1. Okay, next I have 0, 1, 1, 1, 0, 1, 1 and 1. Okay, so I'll be not writing each and every internal numbers of each blocks here. So what is the answer for this? Here I can make what is the answer, simplified expression which I can have here. So this can be one pair. Okay, this can be one pair, and this can be another pair, and this can be another pair. Okay, let's say this is my first pair, this is my second pair, this is my third pair. Okay, so jotting down the answers, what is the answers that we have? Y is equal to AC plus BC plus AB. Okay, so AC plus BC plus AB, you know how to write. So how do I represent this using your logical diagram? So if this is my answer, let's represent it in your logical diagram now. So what is my first? I have inputs A, I have inputs, let's say I take input AC now, AC. So I'll be writing AC. So A, another input is C. I'll give it to an AND gate here. This is my output to AC. Next, plus BC. I have B and C. Give it to an AND gate. The output of AND gate is BC. Next, I have AB. Okay. Next, I have AB. This is my AB. Give it to an AND gate. Output you'll be getting it as AB. So now I'll be subjecting the since there is addition operation, which gate I'll be using? I'll be using OR gate here. 3 input OR gate here. So I'll be taking one OR gate. Okay, so this is my output. So input 1 is this, input 2 is this, input 3 I'll be connecting to this. Okay, so this is Y is equal to this equation. So this is AC, this is BC, and this is AB. Okay, so this is your complete problem. So first go with the question. So for the given question, you'll be writing your truth table. Okay, after writing your truth table, you'll be writing your k-map for this. After writing k-map, you'll be going with your logic diagram. Okay, logic diagram or logic circuit diagram, whatever you may call. Okay, any doubts in this?
No, sir.
No, sir.
Can we continue with the
sir.
next problem?
Yes, sir.
Yes, sir. Yes, sir.
Let's say I'll be considering my second problem. Okay, so design a circuit. Okay, so please take a sheet of paper and try to solve this problem. Design a circuit to detect invalid BCD numbers and implement using NAND gates only. So there are two constraints over here. The complexity of level, the level of question is slightly higher than the previous question. Okay, so what he is asking here, so he is asking to design a circuit to detect invalid BCD numbers. So what is BCD numbers? Can anybody just brief out quickly what is BCD numbers? What is BCD numbers? What is BCD? Anybody? Okay, see, just
Binary coded decimal system.
binary coded decimal. A very good answer. Okay, so we have binary coded decimal means what? Means what? We have the numbers. Okay, let us say we have the numbers. So we have 0. Okay, 0 is represented as 0 in 4 bits. Okay, let us say if I take 1, so 1 is represented as 0001. Okay, you need to know what is invalid. This is binary code representation. Okay, this is binary code representation. What is invalid binary code representation? So there is a beautiful explanation in your the website which I have taken here as Quora. Okay, Quora has given a beautiful answer for this. Okay, so we shall just go ahead with whatever the answer which is given in the Quora. Okay, so he has stated what is the reason behind invalid BCD code mean. Okay, so there is a beautiful explanation which he has given you here. Okay, if you could just read it here, please observe here. BCD uses 4 bits to represent your decimal digits. Okay, so there are 10 digits in your decimal number which starts from 0 to 9. Okay, 0 to 9. How many digits are there? Totally of 10 digits. Okay, so but my 2 power 4, there are 4 bits. Please assume that. What is my 2 power 4? That is 2 power 4 is 16. Okay, so that is 0 0 0 0. That is, this is 2 power 0, this is 2 power 1, this is 2 power 2, this is 2 power 3. Okay, so this is, that is sorry, this is 2 power 1. Okay, okay, if we consider this particular problem, we have 16 possible combinations which we have. Okay, so considering 16 possible combination, let us say, so your 0 is represented as 0000, 1 is represented as 001. Again, likewise, we have till 9. I have 9 can be represented as 1001. It is simply a combination of 8421. Okay, 8 plus 1 is 9. I can represent 9 as 1001. So all digits have been covered. What happens to the remaining possible combinations? Like 4, after 9 we have 10, we have 11, we have 12, 13, 14 and 15. So how many digits are there? 1, 2, 3, 4, 5 and 6. Okay, so what happens to this possible BCD numbers? These are called as invalid BCD. Invalid BCD. Are you people able to understand this? Are you people able to understand this?
Yes, sir.
Okay, so what is the reason behind this? So reason behind this is very simple. Invalid BCD numbers are after 9, whatever the numbers which is present there, after 0 to 9 are valid BCD numbers. From 10 to 15 are your invalid BCD numbers. We just know, we just learned what is valid and invalid BCD numbers. Okay, let's go back to our problem. Let's go back to our problem. See, the problem which I'm having here, the problem which I'm having, let's come back. See, I have the problem here. Where is my problem? Let's say, so this is my, okay, this is my problem. Okay, what does your problem states that design a circuit to detect your invalid BCD numbers and implement using NAND gates only. My first case you have understood, you have to use BCD numbers only. What is my second case? Using NAND gates only you have to design your circuits. Let us see how do we how we try to interrogate with this particular problem. Okay, we shall go with the solution part now. As you can observe here, I have written 4 possible combinations, that is A, B, C and D. Okay, what are all the possible combinations which I can have? 0 to 15. All the 15 numbers I have represented as in your binary digits. That is, 0 can be represented as 0000. Okay, so now what is my solution that I need to go ahead with now? For all the combinations, that is for all the invalid BCD numbers, it will be your circuit must be high. What are all the invalid BCD numbers which I am having here?
10 to 15.
Yes. So 10 to 15, I'll be representing it as 1. So 1, 1, 1, 1, 1. So remaining all other things, I'll be the output will be your 0. So considering this, how can I write my K map here? So K map, I'll just fill my K map values here. So K map values can be filled like this. Okay, I'll be filling with all the values from 10 to 15. I'll be just replacing it by 1 here. So 0, 1, 2, 3, 4, 5, 6, and 7. 8, 9. Now I have 10. That is 1, 1, 10, 11, 12, 13, 14, and 15. Okay. What is the answer which I can get from this K map? I have one quad here. This is my first quad. This is my second quad. So this is my feasible solution. So what is the answer for this? If you consider AB here as my input, CD as my here input here. Okay, what is my answer that you can get from this K map? Y is equal to
AB,
AB,
AB plus
AC.
AC. Good.
AC.
Okay. So AB and AC is my problem. So after getting the Boolean equation, I can just simply write down the logic diagram. So how do I write the logic diagram? I have my input A, I have my input B. So I'll subject it to an AND gate. So this is my output of the AND gate, that is AB. Next I have AC. From this here, I'll be taking another input A. So with this I have C. I'll subject it to another AND gate. So that is my AC. I have my AB and AC ready. What is the sign that I am having? It is the sum operation. That is, I'll be taking OR gate. So two input OR gate. So finally my answer will be Y is equal to AB plus AC. Any doubts in this?
No, sir.
No, sir.
Okay. So now let's consider another example. Okay, here I have written, okay, AB and AC. So simplification can be done over here. Okay, so let's say, okay, so now take down the assignment. So this is your assignment for today's class. So this is one of the assignment for today's class. So design a combinational logic circuit when output is high only when the majority of the inputs A, B, C, D are low. Okay, so this is your question. Please consider this as your assignment. So I'll be telling you how to submit your assignment at the end of this class. Okay, did you finish copy down the question? So design a combinational logic circuit when output is high only when the majority of the inputs, that is A, B, C, and D, are low. How do you interpret this particular problem? Please take it as an assignment. Finished copying down the question?
Yes, sir.
Let's
Yes,
say,
sir.
uh, we'll go with the next thing. See how my very first question is done. So let's come back. Having this as a prerequisite, okay, having these as an introduction to your combinational circuit. See, now we shall go back and just see what is the first agenda of this today's session. We just learned what is the difference between your combinational circuits, difference between your sequential and combinational circuit. An example of combinational circuit is done. Okay, let's take up what is the concept of gate fan-in and timing diagram. Okay, let's see what it tells. Okay, so now I shall just go ahead with that particular concept. Okay. Okay, so now my very first question is, what do you mean by gate fan-in? Okay, so let's say, please understand this concept so that you can just go ahead with you will be understanding the concepts very clearly. Let's say we have some gate, an AND gate. Okay, we have basic gates as AND gate, OR gate, okay, and NOT gate. Any gate. We'll consider this AND gate now. See, AND gate. So I'll be writing AND gate like this. I have two inputs. I have two inputs. The output of two inputs. Let's say this is my input one. This is my input one. This is my input two. Okay, what is the output which I am having? That is A dot B. A dot B is my output. So here y is equal to A dot B. Okay. Let's say I want to change the value of A. I have produced my output. After producing my output, I want to change my inputs so that there is a delay. Okay, so there is a delay in the change of output too. Okay, if there is a change in the input, my output should be again reflected. Okay, let's say 0 0 0 1 1 0 1 1. Okay, so first, this is my first input 0. I'll pass 0 and 0. So what is my output for 0 0? There is some output here. Next, I will change the input to 0 and 1. So after changing it to zeros and 1, so there is a delay which is going to happen with respect to your output. So that delay, I will be calling it as propagation delay. Did you understand? Are you understanding?
Yes, sir.
Okay. So
Yes, sir.
now what exactly is propagation delay? Let's go back now. So this is my propagation delay. So after understanding that, so any gate, your AND gate, OR gate, or anything. So let's say let's say I have a 7404. This is my IC for AND gate. Okay. So let's say we have an IC called 7404 or any other IC. Let's say. So each and every gate has a limited inputs. So suppose if there are two inputs, so this AND gate is for two inputs. Okay. If I want to generate, if I want to subject any extra input, okay. So if I want to add another input, there already existed two inputs A and B. I want to add another input C. Okay. So this we call it as your fan in. Your fan in. Fan in means number of inputs. Your fan in is limited. Okay, so this you need to observe. Okay, so depending on type of gates, let us say some gates can have the capacity to have include two inputs, few gates can accommodate three inputs, few gates can accommodate 4 or 8. I'll be giving you the list of IC numbers with the capable inputs that the IC have. Okay, so having this as a prerequisite, how do you design? So designing of circuits with limited gate fan in. So let us say we have about n number of inputs. I want to design my circuit in such a way that there is limited gate fan in. Okay, so this is my main goal. So how do you interpret this particular problem? Let's see. So now I'll be taking for this. See, any concept can be explained only with the help of examples. Let's take up a small example. Okay, minimize the given SOP expression. Okay, minimize the given SOP expression and implement it using three input NOR gates. Three input NOR gates. Okay, this is what the question here is. So what is the constraint he is giving you here? Minimize the given SOP. What is SOP? Sum of product expression, and implement it using NOR gates only. So the final implementation must be done in your NOR gates only. Okay, this is what the question he means. Okay, so let's say he has given you an equation. So this is what the question. F of, we have four inputs A, B, C, and D. So summation M. So these are all the min terms which he has given you: 0, 3, 4, 5, 8, 9, 10, 14, and 15. Okay, so if he has given you these are all the min terms, it is very easy to plot the k-map directly. Okay, so what will be my k-map? My k-map looks like this. Okay, looks like, oh, I'll be just plotting the k-map now. Okay, we'll just write the k-map for this problem. Okay, so how my k-maps look like? Okay, so let's say I have 4 inputs. I'll be just drawing with the inputs. So this is my k-map. Okay, so I have 4 inputs. So 1, 2, 3, and 4. Here I am having 1, 2, 3, and 4. Okay, so here I'm having inputs. I'll be writing my inputs, that is A, B. I'm having C, D. Okay, so here I'm having for all the values of it is 0, 3. Next I'm having 4 and 5, and next I'm having 8 and 9. Okay, so 8 and 9 here, 8 and 9, and next I'm having 10, 14, and 15. So rest all other I'll be replacing it with 0. Okay, so if you plot this k-map, what is the possible combinations that we can have here? Okay, possible combinations that we can have, and just anybody tell here. So this is my first pair, this is my first pair, this can be my second pair. Okay, so since it is
Sir,
okay, okay,
it's SOP.
okay, okay, sorry, so since this is SOP, I just confused. Okay, since it is SOP, I'll be grouping with your uh, ones here. Okay, so if I group, see, we can just do it in both the ways. Let's see, well, let's go ahead with whatever the possible combination. I'll be writing it as f dash here. See, one way that I can just go ahead with this is I'll be going with grouping of zeros here. Okay, let's see how do we get. So here, if I group this as 0, let's say this is my first pair, this is my second pair. Okay, so this is my third pair. Okay, and next I have zeros here. So this is one way of interpretation, just you people need to know. So this is my, okay, just hold on. Okay, so this is my next single one which is remaining, single zero which is remaining. Okay, let's write the answer for this. So here, can somebody tell me what is the answer for this? So here, if I just make the groups of zeros with the given k map, so what will be the interpretation? See, you must remember that. So here it is 0 0 0 1 1 0 1 1 0 0 0 1 1 0 and 1 1. I'm grouping this as zeros, so it will be your here I'll be having C plus D, C plus D. Here it is C plus D bar. Here I'm having C bar plus D bar. Here I'm having C bar plus D. Am I correct?
Yes, sir.
This is A plus B. This is A plus B bar. This is A bar plus B bar. This is A bar, sorry, that is A bar plus B. So what is the answer which I can have? So my f value, my function value states that f is equal to, I'll be taking these two. Let us say I take this, I'll be writing the answer for this. The answer will be your A plus B plus C plus D bar. Okay, this is my one term into A bar plus B plus C bar plus D bar. This is my second term. This is my next term is I am having A bar plus B bar plus C. Okay, into next how many terms I am having? 1, 2, 3, 4, 5. So how many terms I am done? 1, 2, 3. Rest to two other terms are different. What is my next term here?
A plus C bar.
A plus C bar plus D, and also I'm having, what is my last term I'm having?
A plus B bar plus C bar.
B bar plus C bar, huh? C bar. Okay.
C bar,
So
sir.
these are all my 5 terms which I have got this from this. So students who are not able to understand this mapping, please go ahead with the concept of K map again. So mapping of zeros, I can write it as in this way. Okay. So is there any doubts with respect to subjecting this particular answer? Any doubts? Can we go further?
No, sir.
Yes.
Can we go further? Any doubts here?
No,
No,
sir.
sir.
Okay, cool. So next, I'll be taking only those five terms. Okay, I'll be taking those five terms. So I have written those five terms here. My a bar, b bar, c bar, d plus a bar, b bar, a, b bar, c, d. All my five terms. So this is my term one. Okay, so this is my term one. This is my term two. This is my term three, term four, term five. Okay, so this is my f bar. Please remember this. F is your, when you map for ones, you will be writing it as f. So this is my f bar. So when you map for zeros, I'll be writing output bar. Okay. So now my f bar can be reduced. We need to reduce this particular equation. How do I reduce? Just go ahead with the common things here. We'll try to minimize this particular expression. So considering this is my f bar can be reduced as, what is the common term that we have? So here comparing these two, this is term 1 and term 2. I have b bar d and b bar d as common here. So I'll take b bar d common. What is the remaining things I'm having? A bar c bar plus ac. Next, plus, next I'm having a b c bar. There's no common term. Next I'm having here a bar c and a bar c. So I'll be taking common as a bar c here. So the remaining term is b plus d bar. Any doubts in the first step?
No, sir.
No,
Next,
sir.
see, now I'll be converting my f bar to f. Anyway, see, this whole boolean expression is left to you. Anyway, you can just reduce this particular given expression. I have done in this particular way. That's it. So now your sum of product is again brought down into product of sum. Now I'll be just converting this again, f bar to f here. So it can be your b bar d can be written as b plus d bar. This product term will become sum here, that is plus. A bar c bar is a plus c. Next there is sum here, it will be converted into product. Okay, what is ac? AC will become a bar. There is product, I'll be converting it to sum. This will become c bar. So there is a sum here again. So this term is done. I'll be going ahead with, so it is again product, that is a b c bar, that is a bar plus b bar plus c bar will become c. Next here again a bar c can be written as a plus c. Next here there is product, I'll put the sum here. Here I am having b plus d bar, so it will become, b will become b bar, d bar will become d. Is there any doubts in the second step?
No, sir.
No, sir.
Going with the third step again, I'll just try to reduce this again here. B plus d bar plus a plus c. The same thing remains same here. Next a bar plus b bar plus c. Next here a plus c plus b bar d can be written as b plus d bar whole bar. B plus d bar whole bar. So this is my the reduced expression which I can have here. Okay. So now let's go ahead with. So next I can write my circuit diagram. Say I can write my circuit diagram. What is the answer that we have obtained here? We have obtained the answer. So what is my obtained answer? First I will be writing the obtained equation. My obtained equation is B plus D bar plus I have a plus c into a bar plus c bar. Okay, so this is one term. What is my next? I am having it as a bar plus b bar plus c, and then I am having into a plus c bar plus b plus d bar whole bar. Okay, I think this is my same equation, I think. Is there anything? No? So this is the obtained answer that we have got from the previous example. Let's draw. So after writing this, the circuit will become very much easy. So you can just easily write the circuit. Let's take up this. Let's take up this. Okay. One here I'm having A plus C into A bar plus C bar. Okay. So let's draw here. This is my A, C. So this is my, I'll be writing, subjecting it to one OR gate. That is my A plus C. Okay. So since I'll be writing, I'll be just writing the circuit here, observing the questions. So this is NOR. I need to NOR this. Next I have A bar plus C bar. So here I'm having A bar, here I'm having C bar. I'll be giving to one NOR gate here. Okay, so the output will be like this. Again, if I just give the input to again an OR gate, it will be become A plus C into A bar plus C bar. Okay, so this will be acting one of the input for the product with, this is addition. So this whole term I will be adding this B with B plus D bar. So I have B as one input, D bar as my second input. With this input, I am considering this also. So it is 3 input NOR gate. So this I'll be writing another gate here. Okay, the output of gate is this whole term. Any doubts in this?
No, sir.
No, sir.
Okay, so this is my first term, you are done. So writing the circuit for this is done. Now I'll just go ahead with this. So I'm having A bar, B bar, C. So this is my first input, A bar, B bar, C. So collectively I'll give it an NOR gate here. So the output I'll just leave it again here. Next I'll be writing for third. Okay, this part. So how do I write? So here I'm having what I'm having, B plus D bar whole bar. This term will take. So I'll be taking it as B and D bar. Okay, B is one of my input, D bar. So B plus D bar, I'll be barring it again. So this is B plus D bar whole bar. With that I'm having A plus C bar. Okay, I'm having A and C bar. Okay, so this is my input 1, this is my input 2, this is my input 3. I'll be giving it to another NOR gate here. So the output will be A plus C bar plus B plus D bar whole bar. Okay, so this is one, this will be acting. So combining all these things, so this is my output, one of my output, this is my second output. Okay, this is my third output. I'll combine together. Again, I'll subject it to an OR gate here. Okay, so this is your final output F. So F is equal to this thing. So F is equal to this whole thing. Okay, so this is how you reduce the, see this whole expression. What the question state that in one single NOR gate, can this have any number of inputs? No, it cannot accommodate all these inputs at a time. So that by implementing the concept of gate fan in here, applying this concept, so I have reduced this whole equation into sub circuits so that collectively you can generate your output here. Any doubts in this? Any doubts?
No, sir.
Has everyone understood the concept? Any can just somebody unmute yourself and just let me know whether you have understood.
Yes, sir.
Yes, sir.
Yes,
Okay,
sir.
okay. So if this the case, okay, if that's the case, okay, let's go ahead. So take down this question quickly. So this is your second assignment for this today's class. Okay, minimize the following functions and realize the functions using only two input NAND gates and inverters. Okay, this is what the question. Okay, you need to please consider all these equations. We have inputs f1, function 1, function 2, function 3. Plot the k map for all these things, obtain the equation and apply and generate the circuit. Okay, please go ahead with this particular problem. Okay, I think if you can solve this particular problem, you can understand your concept of gate fan in and delays. Okay, so finished copying down the question. Can we go further?
Sir, we have one more class, sir, at 11.
At 11 you will be having class. I'll be winding up the class in next to 2 minutes. Okay,
Yes,
is
sir.
the
Okay, sir. Okay.
okay? So now the question here is, we have gate delays and timing diagram. So why do we require gate delays? So is my first question. So representation of any circuits, the internal happenings of any circuit can be represented using your timing diagram. See, we have a representation of truth table, we have representation of Boolean equation, we have representation of K map. Okay, we have representation of like see, one of the type of representation is your timing diagram. So this is how your circuit, internal circuit looks like. So clear observation can be done using your timing diagram. We also know that we just studied what is propagation delay. What is propagation delay we studied. Okay, we'll try to take up your example for timing diagram in your next session. Okay. Just hold.